Hello, this is Mr. Yoon. Today we're going to learn about the basics of exponents. Now I'm sure that even though you may not know what an exponent is, you definitely have heard about it. You remember BEDMAS? The thing that all the math teachers scream at you saying, you have to follow the rules of BEDMAS. Exponent is what takes the part of E in BEDMAS. Before you get into the details about exponents, I want to let you in a little secret. Mathematicians are lazy people. As a result, they invented multiplication because they didn't want to say or write, can you add 2 7 times? Which would be written as 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Instead, they shortened it to 2 times 7, which is written with a little cross. Now, what if someone asked you, can you multiply 2 by itself 7 times? And that's where the exponents would come in. Instead of having to write 2 times 2 times 2 times 2 times 2, which would be this, we can simply write 2 with the 7 on the top like this, which we read as 2 to the power of 2 or 7th power of 2. Here, 2 is what we call a base. And 7 is what we call an exponent, or also a power. In other words, the base is the number that is being multiplied by itself, and exponent is the number of times we are multiplying. Now let's try to practice. So what would be 2 to the power of 3? We know that 2 to the power of 3 means that we have to multiply 2 by itself 3 times. We know that 2 times 2 is 4, and 4 times 2 is equal to 8. Therefore, 2 to the power of 3 is equal to 8. So now, just a couple more examples with a little different bases. So what if the base was a 0? So now we know that 0 times 0 is equal to 0. Or in fact, it doesn't matter how many times we multiply 0 by itself, we know that the answer is always going to be 0. So 0 to the power of 2 is 0, and 0 to the power of 5 is also 0, and so is 0 to the power of 1 million. Yep, that is 1 million. So that is exponents of 0. So now, what about if the base was a fraction? So before we do exponents of a fraction, let's review multiplying fractions first. So we know that when we multiply fractions, we multiply the number on the top by the number on the top, and bottom numbers with a bottom number. So for example, if I have 2 to the power of 3 times 5 to the power 2 over 3 times 5 over 7, then I know that I have to do 2 times 5 and put it over 3 times 7, which will then become 10 over 21. So now let's think about what exponents really mean. So let's say we have 2 over 3 and we want to power it by 3. Then we know 2 over 3 to the power of 3 means that we have to multiply 2 over 3 by itself 3 times. So then I have 2 over 3 times 2 over 3 times 2 over 3. Then I have 2 times 2 times 2 over 3 times 3 times 3, which then becomes 2 to the power of 3 over 3 to the power of 3. So here we can see that if we have a fraction and have an exponent, we can just distribute the exponent to both top and bottom. So as a result, a general rule of thumb is that if I have a over b to the power of x, then that is equal to a to the power of x over b to the power of x. And one last example is exponents with negative numbers as a base. So for instance, let's say we have negative 1 to the power of 2. Negative 1 to the power of 2. Then we know that negative 1 to the power of 2 means we're multiplying negative 1 by itself, negative 1. By negative 1, let's say we have negative 1 to the power of 2, which is equal to negative 1 times negative 1, which then becomes a positive 1 since we have two negative numbers. What if we had negative 1 to the power of 3? Then I know that I have to do negative 1 times negative 1 times negative 1. And we just found out that if I multiply negative 1 by itself twice, it becomes a positive 1. Then I just have to multiply positive 1 by another negative 1, which then becomes a negative 1. Let's do it one more time. So for example, and negative 1 to the power of 4 is equal to negative 1 times negative 1 times negative 1 times negative 1, which we know that when we multiply negative 1 by itself 3 times, it became negative 1. And we multiply negative 1 by another negative 1, therefore it becomes a positive 1. So from here we can start to see that the answers to the powers of negative 1 alternate between 1 and negative 1, 1 and negative 1, and 1 and negative 1, and so on and so on. So when we have a negative number inside of the bracket and have an exponent, if the exponent is an even number, then our answer is going to be positive. If the exponent is an odd number, then our answer is going to be a negative number. One thing that you have to be careful about is when negative number is outside of the bracket. So for instance, let's say I have negative 1 to the power of 2. Here, negative is actually not part of this 1. So therefore, we have to do, and this squared is only applying to the 1 there. So this is in fact negative times 1 times 1, which is actually negative 1. So, which is vastly different from negative 1 to the power of 2, which is negative 1 times negative 1, which became positive 1. So one thing that I really want you to keep in mind is that negative 1 with a bracket squared is not the same as negative 1 to the power of 2 that does not have a bracket. Okay, that's it for today. Thank you for watching.